Hi, in this series of videos, we're going to take a look at graphing relations 1. We're going to graph relationships between x and y. We're going to use our tables of values to plot points on a graph. We're going to then graph or draw the lines on the graph. Then we're going to also practice reading graphs and extrapolating from graphs. We'll probably do this in 2 videos. As we discussed, there's 3 ways to show a relationship. First is a table of values between our x values and our y values. From that table of values, we can create an equation. We can also create a visual called a graph. And a graph is just a picture of the relationship between the 2 variables, between x and y. We can use the table of values to draw the graph, or we could also even use an equation to draw a graph of a relation. Graphs are drawn on a grid, and you may have grid or graph paper already. And what we have for most of us, we don't actually think about graphs being in 4 quadrants, which we'll discuss. But a grid looks like 2 intersecting number lines, and right in the middle, where x is at 0 and y is at 0, that's called the origin. And that's that 0, 0 for x and y. The horizontal is the x-axis, and the vertical is the y-axis. I'm going to label that up top there. You may also want to note from the point of origin that to the right and upwards are positive values, and to the left and downwards are negative values. This grid has 4 quadrants. And the quadrants are numbered counterclockwise. So where we have a positive x and positive y, that's our quadrant 1. That's our most popular quadrant where we would see majority of graphs, like in the newspaper or on the news. Quadrant 2 is where we have negative x values and positive y values. Quadrant 3 is where we have negative x and y values. And quadrant 4 is where we have our positive x values and negative y values. A table of values is really just a way for us to make ordered pairs. They're pairs of numbers. So each ordered pair, the x and the y, represents a point on the xy axis. So for example, if I fill in this table of values where I say x is going up by 1, so I could do 1, 2, 3, 4, and let's say that my y values are doing just about the same, but they start maybe at 2, then 3, then 4, then 5, I can create an equation from this table of values, but I can also plot them as plotted pairs or ordered pairs, because this will be point 1, 2, so x is 1, y is 2, 2, 3, 3, 4, x is 3 and y is 4, and 4, 5. And I can plot the points on the graph accordingly. So x is 1, y is 2, x is 2, y is 3, x is 3, y is 4, and x is 4, y is 5. And then from there, I can join the plots to create the equation of the line. And I can even extend this down to cross the y-intercept. In this course, it'll be very important for you to be able to create your own graphs using tables of values and creating your ordered pairs. The biggest mistakes I see are with scale. Scale is very important, and so we're going to spend some time talking about it. What we have in this table is a relationship between time and distance. Time in hours and distance in kilometers. Time is going to be our x, and distance is going to be our y. And that means that time influences the distance. Just as you know, if you're going somewhere, the more time you spend in the car, the further you're going to be able to drive. And so we can create ordered pairs, and then we can also label and set up our graph. So our ordered pairs are going to be x comma y. So we can plot these points, 0, 0, 1, 10, 2, 20, 3, 30. So we can plot these points on the graph, but this graph is not set up for us. So our manipulated variable, the one that is our influencer, that's our time, that's going to go down here, and we're going to label it in hours. And our distance in kilometers is going to go on our y or vertical axis. What we have to do is decide how to make the scale. So if I'm going to make a scale where I have a 0, 0 in the corner, and I always do that because that's my point of origin, I get to decide how many grids I go on the x and how many I go on the y. So I'm going to show this. So I have quite a bit of space here. I only have to plot 3 hours of time. So I may choose to use 4 boxes, 1, 2, 3, 4, to be able to go to the first hour. And if I do that, I have to be consistent throughout the rest of the scale. So then I use 4 more boxes to get my second hour, and I know that's really tight in there. And then 4 more boxes to get my third hour. That's called scale. It has to be consistent. I can't use 2 boxes and then 4 boxes and then 6 boxes, if that makes sense. And then on my y-axis, I'm going from 0 to 10 to 20 to 30. So I'm going up by 10, but again, I get to decide how I want to set up the scale. So maybe I will use 4, or maybe I will use 5. It's completely up to me. I'm going to use 4 boxes, 10, coming from 0. I used 4 boxes to represent 10 kilometers. And I'm going to use 4 more boxes to go up to 20, and 4 more boxes to go up to 30. Notice that I'm not going to use the entire graph, and that's okay. I want to space things out correctly and use as much space of the graph as I can, but I'm not looking for perfect. I'm looking for pretty good. Now that I have my scale set up, my graph will actually be accurate. So at 0 time, I'm going 0 kilometers. So that is my plotted point right there at the point of origin. In 1 hour, I'm going 10 kilometers. In 2 hours, I'm going 20 kilometers. And in 3 hours, I'm going 30 kilometers. And now I can create my graph. I'm not very good at making a straight line. You may want to use a ruler. And so this is a linear equation, which means the line will go up, up, up in the same trajectory, the same slope, as we have a pattern for distance and time. So just to review, it's really important that we know that the independent variable or manipulated variable, or what I call the influencer, that's the one on the x-axis. So things like time will influence distance, number of people might influence how many seats you need to have in a classroom. So those would be our x values. The dependent or responding variable that responds to the influencer, that's the one on the vertical or y-axis. Things like temperature is influenced by time of day, cost might be influenced by inflation, age, wages, those things could be influenced by other factors, like age of, how long people live in a country might be influenced by the type of food they eat, for example. So those types of variables would be on the y. So they depend on x. And remember, right in the corner where x and y meet, that is your point of origin. Now you can give graphing a try by using this table of values up on the top of page 342. So this is a recording of temperature during 4 hours in Jasper. And so you can make your plotted points. Time is influencing temperature. And then you can create the labels on the x and the y axes. And you can plot your points and create your graph. And I encourage you to try this on your own. Pause the video, and then you can compare it to mine. We may not have the same graphs because we may not have the same scale, but ours will look similar. All right, I see that my time is on the x-axis and the time is in hours. It's important to label that. Temperature, I don't have to write it sideways. I can write it out here. Temperature is in degrees Celsius. My plotted points are going to be 5, 30, and 6, 25, 7, 20, and 8, 15. Notice the pattern that's happening for x and y. For x, we have an increasing +1 pattern. For y, we have a decreasing -5 pattern. I need to get my time 5, 6, 7, and 8. I'm going to go ahead and I'm going to start to just guesstimate where I should put them. So at 5 p.m., I used 3 boxes, 6 p.m., 7 p.m., and 8 p.m. I probably could have spread that out a bit more. This is at 0. And then for my temperature, I'm going to see that my lowest value is 15 and my highest is 30. And so I'm going to start maybe up here at 15. And then I'm going to use 3 boxes to go to 20, 3 boxes to go to 25, and 3 boxes to go to 30. Before I plot these points, I want to point out something super important. On my x and y, I am jumping numbers. My scale is off from the start. Notice that I went 3 boxes from 15 up to 20, up to 25, up to 30, representing the +5 going upwards. But from 0 to 15, I also used 3 boxes. That is called a break in scale, and what you have to do is draw a scale break to show that that's not consistent with the pattern you used above, and that's allowed. And it's actually the same on the x. I went from 0 to 5, and then up by 1 from there on. I'm allowed to do that, but I have to show a scale break. So I deliberately created my graph so that I would show you 2 scale breaks. There's so many ways to avoid scale breaks, but sometimes you can't. So I have scale breaks, which means my graph will be good, but I recognize that I don't have perfect scale from the start. Once I have 5 on the x and 15 on the y, I'm consistent from there on. So now I'm going to plot my points. I'm going to put in that at 5 o'clock the temperature was 30 degrees. At 6 o'clock it was 25 degrees. At 7 o'clock it was 20 degrees. And at 8 o'clock it was, at 15 degrees. And now I can draw my graph, draw my line. This is a downward slope because the temperature is going down as the time is going outwards. Lastly, I can give a title, Temperatures in Jasper. And in the next video, we'll go deeper into graphing relations.